Today, our new topic, colloids. It is the third part of the fifth chapter, surface chemistry. Colloids, you have studied it in the 8th standard. We have true solutions, then suspensions. In between suspension and true solution, there is colloids. Based on the particle size, true solution, colloids, and suspension are differentiated. In case of true solution, all the particles are below 1 nanometer in size. The solid particles are below 1 nanometer in size. And in suspension, the particles are above 1000 nanometer in size. But in colloids, the particle size is in between 1 and 1000 nanometer. In between 1 and 1000 nanometer, the colloidal particles, the size of the colloidal particles. So what is a colloid? A colloid is a heterogeneous system in which one substance is dispersed as very fine particles in another substance called dispersion medium. One substance is dispersed as very fine particle. That means of the size 1 to 1000 nanometer in another substance. In another substance. That is called dispersion medium. So one substance is dispersed in another. The substance which is dispersed is known as dispersed phase, and the substance in which it is dispersed is known as dispersion medium. So dispersed phase and dispersion medium. For example, starch salt, that is a colloid. When you heat starch with water, you will get a mixture. We cannot call it as a true solution. We cannot call it as a suspension. In between the two, that is a colloid, colloidal solution of starch. We can call it as starch salt, in which starch is the dispersed phase and water is the dispersion medium, starch salt. Again, already I mentioned the three terms: true solution, colloid, and suspension. In true solution, what is the particle size? Below 1 nanometer. In colloid, what is the particle size? In between 1 and 1000 nanometer. And in suspension, what is the particle size? Above 1000 nanometer. Is it clear? So because of this difference in the particle size, their properties are also different. True solution, you know the definition, it is a homogeneous mixture. So true solution is homogeneous, but colloids and suspension are heterogeneous in nature. Colloids and suspensions are heterogeneous in nature. True solution, it will not settle down. If you keep it for a very long time, the true solution will not settle down. But colloids, that also will not settle down. Means gravity has no effect. But suspension, that will settle down if you keep it for some time. And if you pass light through a true solution, it will pass without any restriction. So we can say true solutions are transparent. But colloids are not transparent. That will allow the light to pass through it, but there is a small restriction in it. So we can say colloids are translucent, not transparent, but translucent. But in the case of true solution, they are opaque. True solutions are opaque. So if all these things you have studied it in the 8th standard, I think so. These comparisons and everything. So you have to remember it. Only to recollect, I explained these things here. Now we can directly go to the colloids and its classification. And this colloidal particle, one of the peculiarity of these colloidal particles, they have enormous surface area per unit mass. Because of its small size, it has large surface area when you compare it with its mass. That is one of the important peculiarity of colloidal particles. Now we can go to the classification of colloidal particles based on dispersion medium and dispersed phase. The colloidal particles are classified into 8. These are the 8 classes of colloids based on dispersion medium and dispersed phase. Dispersed phase solid and dispersion medium solid. We can call it as solid in solid type colloid. Solid, dispersed in solid. You may remember the classification of solutions. A similar classification. Solid, dispersed in solid. We'll call it as solid salts. Name of the colloid or type of the colloid, that is solid salt. Solid is the dispersed phase and solid is the dispersion medium. Solid, dispersed in solid. That is solid salt. Example, colored glasses, gemstones. They are examples of a solid salt. Solid, dispersed in solid. Now, solid dispersed in liquid, that is simply known as salt. Solid is the dispersed phase and liquid is the dispersion medium. Solid dispersed in liquid. Its name is salt, or the type of the colloid is salt, simply salt. Paints, example. Then cell fluids, another example. Then starch salt, solid dispersed in liquid. Starch, solid particle dispersed in water. Starch salt, gold salt. All these are examples of salts. One of the common type of colloid is salt. Next, a solid dispersed in gas. Dispersion medium is gas. The type is aerosol. Type of colloid is aerosol. The name of the colloid is aerosol. Example, smoke, dust. Dust particles dispersed in air. So solid dispersed in gas, smoke. Carbon particles dispersed in air. Now the fourth one, liquid dispersed in solid. That is known as gel. Liquid dispersed in solid. What is the name or type of the colloid? Gel. Example, cheese, jellies. Now you are familiar with the jellies. In cheese, liquid dispersed in solid. Now the fifth category, liquid dispersed in liquid. The type of the colloid is emulsion. Liquid dispersed in liquid. Liquid is dispersion medium and liquid is dispersed phase. So liquid dispersed in liquid, emulsion. Milk is an emulsion. Hair cream, butter, all are examples of emulsions. In milk, fat molecules are dispersed in water. So liquid dispersed in liquid, emulsion. Liquid dispersed in gas, that is known as aerosol. Solid dispersed in gas, also known as aerosol. Liquid dispersed in gas, aerosol. And solid dispersed in gas, we can call it as solid aerosol. Liquid dispersed in gas, simply aerosol. The two cases we can use the name aerosol. Example, fog, mist, cloud, insecticide sprays. All these are examples of liquid dispersed in gas. Now gas dispersed in solid. Solid foam, that is solid foam. Example, foam rubber. Rubber that will solidify and its foam also will solidify in that way. Foam rubber is an example for solid foam or gas dispersed in solid. Another example is pumice stone. Pumice stone, I will show the figure of the pumice stone in the next slide. And the eighth one is gas dispersed in liquid. That is simply known as foam. Froth or soap lather are examples for foam, gas dispersed in liquid. The classification is very similar to the classification of solution, but there are 9 types of binary solution, here only 8 types, because the 9th one is not possible in the case of colloids. Gas dispersed in gas, that will be always a solution, not a colloid. Therefore, such a category is not here. Only 8 types of colloids. I think it is clear to you. Now you can see the figures of some colloids. The first one is pumice stone. It is pumice stone. You can see it contains a lot of foam on its surface due to the dispersion of gas in solid, pumice stone. This colored glass, solid particles, colored solid particles are dispersed in solid glass. This one is fog, and it is mist. Some of the examples are colloids from our surroundings. Okay, next classification. Based on the affinity of dispersed phase and dispersion medium, it is classified into 2. Lyophilic colloids and lyophobic colloids. Lyophilic colloids and lyophobic colloids. Lyophilic means dispersion medium loving or liquid loving. Liquid loving, that is the meaning. Lyophilic, liquid loving. Lyophobic, liquid hating or solvent hating, that is the meaning. If the solvent or a medium is water, we'll name it as hydrophilic and hydrophobic. Hydrophilic and hydrophobic. Lyophilic colloids, they are solvent-loving colloids, but lyophobic colloids are solvent-hating colloids. We can compare the properties of lyophilic colloids and lyophobic colloids. That will help you to understand what is meant by lyophilic colloids and what is meant by lyophobic colloids. The first one, solvent-loving. Lyophilic colloids are solvent-loving colloids. Large affinity between the dispersed medium and dispersed phase. Lyophobic colloids are solvent-hating. Means the mixing is difficult. Another important difference. The lyophilic colloids can be prepared directly by mixing the dispersed phase and dispersion medium. Already mentioned the preparation of starch salt. Simply by heating starch and water, we can prepare starch salt. Mixing is enough for the preparation of lyophilic colloids. But direct methods cannot be applied in the preparation of lyophobic colloids. For the preparation, there are only indirect methods. Lyophilic colloids are stable due to strong interactions between the dispersed phase and dispersion medium. They are stable and not easily precipitated. But lyophobic colloids can be easily precipitated by adding small quantities of electrolytes. When you add electrolyte, lyophobic colloids will be precipitated or coagulated. Coagulation means separation of dispersion medium and the dispersed phase. That will be separated. Because of the strong affinity, lyophilic colloids are highly solvated or highly hydrated. Solvated means the dissolution in the solvent that will take place. Highly solvated or hydrated, the particles will be surrounded by solvent molecules. But in the case of lyophobic, not much hydrated or solvated. And lyophilic colloids are reversible in nature simply by mixing dispersed phase and dispersion medium. Even after coagulation, simply by mixing dispersed phase and dispersion medium, we will get the colloid again. But in the case of lyophobic colloids, it is irreversible. After coagulation by simple mixing of dispersed phase and dispersion medium, we will not get the colloid back. So it is irreversible. Lyophilic colloids are usually formed from organic substances, but lyophobic usually formed from inorganic materials. Another important difference. Lyophilic from organic substances and lyophobic from inorganic substances. After the formation, the viscosity is higher than the dispersed medium. Because of the dissolution, the viscosity is higher than the dispersed medium. In the case of lyophilic colloids, but in the case of lyophobic colloids, viscosity is almost same. There is not much hydration or solvation. So the viscosity is almost same. There is no change in the viscosity. And if you consider surface tension, in the case of lyophilic colloids, surface tension is usually lower than the dispersion medium. But in the case of lyophobic colloids, surface tension is nearly the same as that of dispersion medium. So it is the classification based on the affinity between dispersion medium and dispersed phase. There is one more classification that is based on the size of the colloidal particles. Size of the colloidal particles. Based on the size of the colloidal particles, it is classified into three: multimolecular colloids, macromolecular colloids, and associated colloids. There are the three types based on the particle size. It is classified into three: multimolecular colloids, macromolecular colloids, and associated colloids. What is meant by multimolecular colloids? One colloidal particle is obtained by the combination of a large number of molecules. Molecular size will be less than 1 nanometer, but when it forms a colloidal solution, what happens? Many such molecules combine to form a particle of colloidal size. That means in between 1 and 1000 nanometer. So what is multimolecular colloid? On dissolution, a large number of atoms or smaller molecules of a substance aggregate together to form species having size in the colloidal range, that is 1 to 1000 nanometer. Molecular size less than 1 nanometer. So what happens when it forms colloid? Many molecules combine together to form a single particle of colloidal size. That means in between 1 and 1000 nanometer. That is multimolecular colloid. Multi-molecules gives one particle of colloid. Gold sol is an example. Sulfur sol, another example. Examples of multimolecular colloid. The second one, macromolecular colloid. From the name itself, you will understand what is macromolecular colloid. A molecule itself in colloidal size. That means molecular size is in between 1 and 1000 nanometer. Usually polymers form such colloids. Starch sol is an example. So in macromolecules, its size is suitable for colloidal size. Suitable, that means 1 and 1000 nanometer. So macromolecules form solutions in which the size of the macromolecules may be in the colloidal range 1 to 1000 nanometers. These colloids are stable and resembles true solution because a single molecule dissolves to form the colloids. Starch salt, cellulose salt, protein and enzymes are examples for macromolecular colloids. Now the third category, associated colloids or miscellaneous. Associated colloids or miscellaneous. What are associated colloids or miscellaneous? These are some substance in dilute solution it will act as electrolyte, and in concentrated solution it will act as colloid. They are known as associated colloids or miscellaneous. So at a low concentration behave as normal strong electrolytes, but at higher concentration exhibit colloidal behavior due to the formation of aggregates. They are known as associated colloids or miscellaneous. The aggregated particles thus formed are called miscellaneous. At concentrated solutions, the ions combines to form an aggregated particle, and that particle is known as miscellaneous. Miscellaneous are also known as associated colloids. And for the miscellany formation, there are some conditions. The first one is temperature. For the formation of miscellany, a particular temperature is needed, or the formation of miscellany is possible only above a particular temperature, and that temperature is known as Kraft temperature, represented as Tk. So miscellany formation is possible only above Kraft temperature, Tk. And miscellany formation is possible only above a particular concentration. At a concentrated solution, miscellany formation will take. So there is a requirement, a minimum requirement for the concentration. And that concentration above which miscellany formation takes place is known as critical miscellany concentration or CMC. Examples for miscellanies or associated colloids: soaps and synthetic detergents. Soaps and synthetic detergents. I think it is enough for today. In the next class, we can discuss the miscellany formation in detail with the help of the example.